Today we look at section 11.4, the cross product. You can see that many applications in physics, engineering, geometry involve finding a vector in space that is orthogonal to two given vectors. To find this vector, we use something called the cross product, and we can calculate it using standard unit vector form. Okay, so because a cross product yields another vector, it's sometimes called the vector product. We'll call it the cross product. Here's how it works. If I've got a vector u and here's its combination, u1 I plus u2j plus u3k, and v is equal to v1i plus v2j v3k, the cross product of u and v is this vector, u cross v, and that's how we say it, is equal to u2 v3 minus u3 v2i, quantity times I, minus, and here's a big minus, make sure you recognize that, and you can read the rest of this. And you might say, Mr. Ring, how am I ever going to remember that? And that's a good question, and let me show you how. Alright, before we get to that, I want to indicate something that we don't typically do in this class, and you may not have seen in any of your math classes, something called the determinant. So if I have three numbers, let's say that's four numbers, excuse me, a 3, a 4, a 1, and let's say a -2. And I want to find the determinant. So if I call this a sum matrix A is equal to this, the determinant of A is simply found by doing this. We take 3 times -2. I should never pick 3. It's a hard number to write. 3 times -2 minus 1 times 4. So that answer, 3 times -2 is -6 minus 4 is equal to -10. And it's just a number. That's called the determinant of that matrix. Okay? And so we're going to be using that concept here. A convenient way for us to calculate uv is to set it up in this form. Okay, notice u and v are three-dimensional vectors. They're not 2D, they're 3D. And so the first thing we do is put the I, j, and the k on the top. And then we substitute the u1, u2, u3, the coefficients of the I, j, and k in the second row. And then the v1, v2, v3 we substitute in the third row. Okay? Now, in order to make this work, to come up with that formula that you saw in the previous slide that you see right here, we're going to consider, in essence, crossing out or putting a line through the first two. Now, I would not encourage you to write all of these every time, and you'll see an example of me doing this later. But we, in essence, ignore the first row and first column and just find the determinant of these two. So it's u2 times v3 minus v2 times u3. And that's exactly what I've got right here. And you'll see me circle the subtraction sign. It's important to remember that the j term is going to be negative. However you remember that, good for you. All right. So we go across here, and I'm going to cross off the I, and then since I'm doing the j term, I cross off the j column. So now u1 times v3 minus v1 times u3, which we see right here. And finally, the third one again is plus, and this time I cross off this first row and this last column, and I get u1 times v2 minus v1 times u2. That's basically what we work with, and we get that third one right there. It looks complicated. Once you get the hang of it, it's not too bad. Just have to be careful in your calculations. And here's an example of the determinants. I already showed you that, so we won't look at that one again. Oop, let me erase this. Okay, so we're going to do a couple examples here. I've got 3 for you. I think maybe we'll do 2 here. So if I've got u is this I minus 2j plus k, and v is the vector 3i plus 1j minus 2k, find the following, u cross v. So let's take a look at u cross v first. Pretty soon. All right, u cross v is equal to, and again I set that up with my matrix. Here's I, here's j, and here's k. And underneath them I put 1, -2, and 1. And the v vector I have 3, 1, and -2. Now you'll notice example 2, and I'm going to let you do that on your own, is v cross u. In that case, the v coefficients will be in this row, and the u coefficients will be in the bottom row. Okay, so this is equal to, now since I'm doing the I term first, I, in essence, in my mind anyway, cross off the ijk and the column I, so I get the determinant of this, and I'm going to go ahead and write it out for you. I have to do, just so you see. That's -2. So it's that times I minus, because it's the j term, and then we're going to get the determinant. I got 1, 1, 3, -2. Times j plus, and crossing off the k column, I get 1, -2, 3, 1 times k. And that now is equal to, let's do this, -2 times -2, -4 minus 1 gives me 3i minus 1 times -2 minus 3 gives me -5, I believe. Be real careful when you're doing this. That's where you make mistakes. 1 times 1 is 1, minus 3 times -2 is 6, -6. So I get 1 minus -6 is plus 7. Okay. And so when I take a peek at that, does it look okay to you? 3, 5, 7. Yes. So this would be minus, a negative is plus. Okay, let's take a look at v cross v. And again, you're going to fill the columns I, j, k, and v is 3. Since I'm crossing itself, I get 3 and 3. I get 1, 1, -2, -2. And this time I'm going to try to do those things in my head. And I don't know if it's going to work for you or not, whichever way you feel comfortable with. But since I'm doing the I term first, I cross that off. 1 times -2 is -2 minus -2. So I get 2 minus -2. Again, these are not determinant. I've already figured out its determinant. Times I minus, and then I do the j column. I get 3 times, that gives me -6. Minus 3 times -2 is -6. Okay, and that'd be j plus the k term. Oops, I want that to be a parenthesis. Cross off the k's there, I get 3 minus 3, that's obviously 0. That's maybe curious. These all look like it's 0i minus 0j plus 0k. In other words, that's the 0 vector. It's not just okay. Anyway, so let's see. We've got some properties here. I've got u cross v is equal to the opposite of v cross u. Let's see if you figured that out when you did the previous example. If you haven't done it yet, go back and do that. And here I've got a distributive property that appears to work. And notice that this is not commutative. It doesn't just go backwards. That's negative. I've got a scalar multiple involved there. U cross the 0 vector is the same as the 0 vector cross u, and so forth and so on. Some other things that you should know: u and v are non-zero vectors in space. Theta is the angle between them. Then u cross v is orthogonal to both of them, which is really handy. Sometimes we want to know what's orthogonal to both, so we're going to use that one. And here's an application piece that you're going to see. I'm not going to use this one, but you'll see a connected video that Patrick JMT uses that is really handy to use this. So that's very nice. As long as theta is the angle between these two vectors. And then u cross v is equal to 0 if and only if u and v are scalar multiples of each other. Okay. And finally, the magnitude of u cross v is equal to the area of a parallelogram having sides u and v as adjacent sides. You'll get to do that in some of your homework as well. I won't do an example of that. I think you get the hang of that. So here, something for you to consider. We can have, if I have u cross v, and I've got vectors I, j, k, and it appears in this is what we call a right-handed system. Okay, you can see u cross v, it's coming this way. It's in essence, if you were holding your right hand up and bringing your fingers to the pad of your hand. That's u is the outside and your pad of your hand is the v. It's bringing it together. If I did v cross u, it's the other way around, so it has to be your left hand. We'd call that v cross u, a left-handed system. Try it with your hands just to see. Right, we got the answers again. Right here it says find a unit vector that's orthogonal to both of these. We'll try to get this done. If I pick u cross v, so it says u cross v is a vector that's orthogonal to both. This says find a unit vector that's such. All right. So I want you to compute that u cross v right now, and I'm going to pause the video. I want you to come up with that. All right, you should have come up with this vector, -3 to 11. If you haven't, just we can go back and we can work with each other. But you can see here's two vectors. This is -3 to 11 is orthogonal to both of the other two, not just one, but both of them. It says find a unit vector. So in order to do that, we need to take the magnitude of this one. So the magnitude of u cross v is equal to, if I do that, it's the square root of 9 plus 4 plus 121, which is equal to square root of 134. All right, so the unit vector then would be -3 over radical 134 2 over radical 134 and 11 over radical 134. And finally, our time is getting short, but in one of the applications here, we can find the moment or the torque of a force about a point P. And so you know things turn. You think about a wrench. You think about various different things. Even your body has torque, different things. That moment is found by taking the cross product of the distance with the force. And so as you go through this, and I've got this video. If you're watching it live, you can click this video in class. If you're watching it at home, I put that video on there. It's a Patrick JMT video. He does a nice job. Pretty simple way to come up with this. If you follow along in your textbook with their example, it looks more challenging, but it's just watch this attached video and you're gonna feel like I can do that. It's all about the two vectors and then the angle between them. So that's how we measure torque using cross products. All right, have a good day. Goodbye.